Maybe you've heard or read about these. Perhaps you've heard or seen words like these. This course is about all of these and then some. Welcome to Analytics and Predictive Modeling. My name is Dr. Jeff Nicely of the Institute for Quantitative Biology at East Tennessee State University. This is a course on big data and the techniques used to study big data, in particular analytics and predictive modeling. Analytics is a business word. Predictive modeling, for the most part, are algorithms. You may have heard the word predictive analytics, which is a combination of these two. Aren't all models predictive? Well, actually, there are descriptive models and there are predictive models. Descriptive models, they begin with assumptions. You get a model, you collect some data, you estimate parameters, and then you make predictions from the models. Predictive models, on the other hand, begin with these very large, complex data sets. And you have a question. In order to answer that question, you apply algorithms, and then you assess the results. Now, the reason for predictive models is big data. Modern data sets are very large, very complex. They're also very good. Unfortunately, descriptive models are not good at extracting information from such big data sets. So we tend to use predictive models, algorithms. And these algorithms are used in a number of different ways, as you can see here. So what is the predictive modeling approach? You start with a set of big data. You explore and see what the data is like. Often there's a pre-processing step where you transform the data and perhaps you rescale it. Now, once you are at this point, you go to the data mining allegory. The data mining allegories where you want to separate valuable information from the rest of the data, and then you want to assess the results. For example, small social networks like these are constructed from Facebook and Twitter and things like that. A natural question might be to suggest a new friend or a new product to somebody in the network. And as you can see, it's highly connected, and that high connectivity can be used to suggest other connections. Another example is genomic data. This is the first 100 rows out of about 20,000 in a set of data. And this set of data was collected from a number of different experiments. The experiments resulted in different expression levels, and these expression levels, which you can see with the colors there, are used to rank genes with statistical measures, measuring how well those things were ranked. Now, the focus is always on big data. You think of big data in the data mining allegory as the ore, and a few valuable nuggets of information embedded within it. But these tend to be very hard to find. Therefore, we use these algorithms to search for the gold, to search for the nuggets. Now, a good example of this are what are called classifiers. So you can think of panning for gold as being gold is class 1 and all the rest is class 0. And your goal is to find class 1, which is the gold. Now, there is a large theory behind this, and that is that big data is large. In particular, it's extremely large. And it's large because it's also very complex. That means that there are unpredictable processes mixed in with regular processes. A complex system is a large mixture of regular predictable processes and nonlinear unpredictable ones. This course looks at the concepts and ideas used to study the data produced by these systems. So in this course, we have a couple of goals. Our first goal is to introduce the methods considered data mining and predictive modeling. Our second goal is to explore what it means for a data set to be complex.